Hi kiddos. All right, this is our last unit. Kind of really makes me sad. As some of you already know, I am moving into a new role next year. I will be an assistant principal at Newport Middle School, which is awesome, and it's exactly what I wanted, but it's also tough because I'm leaving the classroom for a long time. And obviously I'll be in classrooms and I'll see you guys, but it's going to be different. And so this is my last unit, which is kind of weird. It's my last time teaching kids math, like a whole unit. Obviously, like I'll come in and help you guys, and I'll be teaching you in other ways, and I'll be teaching adults, but this is new for me. So my last one. And so we are going to do Pythagorean theorem. It's a very awesome and very important skill for the rest of your math career. So Pythagorean theorem, I'm sure you've heard it used before. And it fits well since we've been doing geometry. It's a really big geometry unit. So Pythagorean theorem. Your EQ, let's zoom that in a little bit, is what is the PT? I'm going to shorthand because you know I'm lazy. And what is it used to do? Now, generally, if we weren't, in a global pandemic, I'm going to use a darker color. If we were in a global pandemic, this would be a lot different. Okay, we would be learning this differently. I'd have an explore activity, but I just have to get to it, and the videos can't be that long, or YouTube doesn't let me upload them. So I'm just going to kind of teach it to you. I'm sorry, it's not my style, but we got to do what we can do. So the Pythagorean theorem. Okay, you've seen it, you've heard it. I guarantee you, it's a squared plus b squared equals c squared. Okay, it's a phrase you'll use a lot. You'll hear it. It's just something to know. A squared plus b squared equals c squared is the Pythagorean theorem. And what that is saying, that in a right triangle, only right triangles, if we call this A, B, and C, that always a squared plus b squared will always give you c squared. Always. It's like a weird, crazy thing that's kind of cool about right triangles. And again, we know that in sides of triangles, A and B can be switched. Those can be back and forth, so I'll put or B or A, but that is always C. C is always the hypotenuse. Let's write that down just to make sure we have it. Hypotenuse. Hypotenuse, it's the longest side of a right triangle, okay? The longest side of a right triangle is called a hypotenuse. So C is always that longest side. So A and B, as we know, in addition, order doesn't matter, so we can switch them, but C must always be what C, always. The longest side is always C. So the angle that's like the side length that's C directly across from that 90-degree angle. So let me show you what this means. Now I'm going to teach you, we're going to practice it. I promise this is kind of crazy, but I promise you, you will get this, okay? So let's just write that. Oh, and what it's used to find is it's used to find side lengths of right triangles. Underline right. Okay. You can use this to find the side lengths of any right triangle. So the Pythagorean theorem is a squared plus b squared equals c squared. It's always true, and it's always used to find the side lengths of right triangles. And A or B can be switched, but C is always the longest side, okay? The one across, the one that goes diagonal from the 90-degree angle. Okay, so let's go ahead and let's try this out. So if I gave you a triangle, okay, draw my 90-degree angle, and I said this is 3 and this is 4, what is C? Now we don't know. I mean, you can get a ruler out, but you can't do that the rest of your life, and sometimes it's going to be in miles, and you can't get out a ruler for miles, okay? So how we use the Pythagorean theorem is we plug in what we know, we substitute it into our equation. Okay, so we take what we know and we substitute it into our equation. So I'm going to say, okay, I'm going to say 3 is A, 4 is B, and C is C. That works out. So wherever I see an A, I'm going to plug in a 3. Wherever I see a B, I'm going to plug in a 4. Again, it doesn't matter which one's which on the A's and B's. Okay. So a squared, so 3 squared plus b squared plus 4 squared will give me c squared. Okay, that doesn't seem that hard, because do we know what 3 squared is? What's 3 times itself twice? 9. Plus, what's 4 times itself twice? 16. Okay, equals c squared. Well, we know that 9 plus 16 is 25 equals c squared. So some of you might think, oh, okay, so the c is 25. We have to work backwards to find what c is. I know some of you in your brains already know what number times itself twice makes 25. I get that, but we got to practice doing the right process. So in order to get c by itself, we do the opposite. So what's the opposite of squaring? Square rooting. The opposite of squaring is square rooting, and what I do to one side, I must do to the other. So then I get left with the square root of 25 is positive or negative 5 equals c. Well, we know that side lengths can be negative, so we know that c is just positive 5. This length c is positive 5. Isn't that crazy? So by using this magical formula called the Pythagorean theorem, which is a squared plus b squared equals c squared, we are able to find out any of the side lengths of a right triangle. We used the Pythagorean theorem in this problem to find the hypotenuse, or c, because we just plugged in a and b. We followed the order of operations and did squaring first, then added. Then to get c by itself, we had to do the opposite. The opposite of squaring is square rooting, not dividing by 2. The opposite of squaring is square rooting. And so we square root 25 and we get 5. Pretty cool, huh? Let's do another one. We'll do just lots of examples today. Today we'll just be practicing this formula. We won't go into more depth, okay? Let's do another example. Let's do, okay, this here, not going to be drawn to scale because I don't want to use too much paper. Let's say that's 5, that's 12, and this is c. Okay, so the question is, how long is c? If I don't know how long a side length is in a right triangle, I use the Pythagorean theorem. So I'm going to label this a and this one b, and that is c. So all I need to do is take these numbers and plug it into the Pythagorean theorem. A squared plus b squared equals c squared. Okay, I'm just following my formula. A squared plus b squared equals c squared. Well, now I just follow the order of operations. 12 squared is 144, and 5 squared is 25. Add those together and I get 169 equals c squared. To get c by itself, I have to do the opposite operation. The opposite of squaring is square rooting. And the square root of 169, don't you wish you had the red number line right now? All those whole square numbers. I know you probably wish you did. We get positive or negative 13 equals c. Well, we know that a side length can't be negative, so we just know it's going to be c equals 13. We used the Pythagorean theorem by plugging in a and b into a squared plus b squared equals c squared. So we plugged in, we followed the order of operations, and we square rooted to get x by itself, or c by itself. Let's write down those steps just to make sure we have them. So step 1 is plug in what you know. Step 2 is follow the OO, order of operations. Okay. So plug in what you know, follow the order of operations. Okay. Then square root to get by variable by itself. And then use positive value. Okay, so we plug in what we know to plug in what we know, and let's say what we're plugging it into. We're plugging it into a squared plus b squared equals c squared. We then follow the order of operations by doing the squaring first, then we add. To get c by itself, we square root both sides, and then we know because it's a side length that can't be negative, so c equals positive 13. Okay, I'm going to do a couple more. I'm going to do one more straightforward one. Then we're going to do a couple work backwards one, and then that will be it for this lesson. Like I've always said, if this is too much for you, you set up a Google Meet with me, you watch Core Focus, you watch Khan Academy, you watch YouTube. Pythagorean theorem is not new. I'm not the only person to teach it. It's been taught thousands of times by people probably brillianter than I. So if I am not cutting it, this digital Miss Minch isn't there, please use your resources. Core Focus, Khan, YouTube, your parents, your siblings, your friends, me on Google Meet, okay? It's really hard for me to do distance learning, especially with such a complex topic. So I know that you need more support, and I am here for you. Okay, we'll do one more straightforward example. I'm going to do numbers that aren't so nice. The other ones, they're nice, and we'll find out why they're nice. The other ones are nice. Numbers aren't always that way. We know that math isn't always just perfect whole numbers. Okay, so we're going to do a not so nice one. Do 7, 18, and C. Okay, my first step is just decide which one's A and which one's B. It does not matter, but that one is always C. So step 1, plug in what I know. I know A is 7, so 7 squared. B is 18 plus 18 squared equals C squared. Now I follow the order of operations. 7 times 7 is 49. Now 18 squared I know by heart because I've worked with math a lot, but if you don't know, I will reteach you how to do that. Oh, come on, calculator. Oh my God, I opened up calendar. Okay, that was my fault. Okay, so if I have my phone or whatever you want to use, I do 18 times itself twice can work. So I get 324. Or what I can do is if I have a more advanced calculator, I swipe. Okay, I'm going to do 18 to the caret 2. That's saying to the power of 2, and I get 324. Same thing. Equals C squared. Now I'm going to add these together plus the 7 squared, which is 49. And I get 373 equals C squared. To get C by itself, I square root both sides. I get C equals positive or negative. Okay. Now in my calculator, I'm going to reteach you how to do this. If you do the to the 0.5, so if you raise anything to the 0.5, so to the 0.5 is the same as square rooting. Raising something to the 0.5 is the same as square rooting. I get C equals 19.31. We'll just round to the 100th for now. So then I know that it's going to be the positive value. So that side length, that hypotenuse, is positive 19.31. That would be my final answer. Okay, so I plugged in what I knew, 7 for A, 18 for B. I followed the order of operations. To get C by itself, I square rooted. When you square root, you can raise it to the 0.5. Okay, and I got 19.31 positive because side lengths can't be negative. Now what's cool about Pythagorean theorem is if that works to find C, you can also use it to find A or B. So you might get a situation where where you have to work backwards to find a side length. You can't just plug in A and B. Remember, this is always C, always. So then I can just pick, I'm going to make this one A and this one B, okay? So step 1 on our notes say to plug it in. So A, 24 squared plus B squared equals C squared, so 26 squared. I plugged in 24 for A, B for B squared, and 26 for C. Iris is right. Yeah, Iris is with Jamie. Okay, so now I have to follow the order of operations. 24 squared. I get my calculator out. I hit 24, raise it to the second power, and I get 576 plus B squared. I don't know what it is, so I just leave it like that. Equals 26 squared. 26 to the 2 equals 7676. Okay. Now, here's where it gets a little trickier. Okay. I still have to follow solve for variable. So I'm going to go like this. I cover up my variable. How do I get rid of 576? I subtract 576 from both sides. Those cancel. I'm left with b squared here. That equals 100. How do I get b by itself? The opposite of squaring is square rooting. Well, I know the square root of 100. I've done that a million times. B equals positive 10 because it's going to be a side length. So when you have to solve for a or b, you follow the same process. You plug in your a, your b, and your c. Okay, but this time, instead of just being able to add and then square root, you have to subtract and then solve for a variable. So it was the same process here. A went in for A, B went in for B, which was just B. 26 went in for C. I did the order of operations by simplifying. I did the order of operations simplify. To get B by itself, I do the opposite, so I subtract 576. To get B by itself, if B squared, oops, that's already there. If B squared equals 100, to get B by itself, I square root both sides, and I get B as 10. Let's do another one of those. Okay. Let's do another one where you have to solve for A, B, or C. I'm sorry, we have to solve for A or B. Oh, this is not a right triangle. Horrible example. (15, 9, x). Okay. My first step, plug in what I know. So I'm going to call this is always C. The hypotenuse is always C. I'm going to call that A. I'm going to call that B. Doesn't matter. Okay. So A squared, 9 squared, plus B squared, x squared, or B squared. It doesn't matter. It's just a variable. Equals 15 squared, because that is C. A squared plus B squared equals C squared. Now I follow the order of operations. 9 times itself twice is 81. I don't know what B squared is, so I have to pull it down. 15 squared is 225. Okay. Now, in this case, I have to now solve for a variable because I have numbers and letters on one side. So I have to solve for a variable. I cover up my variable. To get rid of positive 81, I subtract 81 from both sides. I'm going to get 4, borrow, 3, whoa, 225, 12, 4, 144 equals B squared. To get B by itself, I square root it. Again, if you need help, you just raise it to the 0.5, or if you need, there's sometimes a square root button on your calculator. Square root both sides, and I get B equals positive or negative 12, but I know because it's a side length, it needs to be positive 12. Okay, we're just going to recap what we've learned today. That's going to be it for today. You're going to go practice this, and then we'll learn like how to use this and apply it and stuff like that. So step 1, what is the Pythagorean theorem and what does it use to do? So we went over this. The Pythagorean theorem is one of those things you have to memorize, just like slope is change in y over change in x. Okay, a squared plus b squared equals c squared. It's used to find side lengths of a right triangle. It only works for right triangles. The a and the b can be switched, but the c is always the hypotenuse. So how do we use this guy? We plug in what we know into the equation and then solve using math practices we've used our whole lives. So if 3 is A and 4 is B, again, it doesn't matter. I plug in 3 for A, 4 for B, and then C is just C squared. We don't know what it is, so we leave it as a variable. So now we follow the order of operations. 3 times itself twice is 9, 4 times itself twice is 16. Now I follow the order of operations and I add it, and I get 25 equals C squared. To get C by itself, I have to do the opposite of squaring. The opposite of squaring is square rooting. The square root of 25 is 5 or negative 5, but we just keep the positive 5 because side lengths can be negative. Same here. A squared plus B squared equals C squared. We squared our numbers. We added them. We square rooted C to get C by itself, and we got positive 13. Plug in what you know. Follow the order of operations, square root to get the variable by itself, and then use the positive value. Now sometimes, in this case, it's not always going to be nice numbers. We have to be okay with that. We have to be able to use our calculator to find square roots. A for A, B for B, C for C. 7 squared is 49, 18 squared is 324. Add them together. To get C by itself, we square root. Usually go to like the 100th or just whatever the worksheet or the test question says. If it says 10th, you go to 10th. 1000th, you go to 1000th. Okay, so you square root by putting it to the 0.5. You do the caret to the 0.5 is the same as square rooting, and you get C as 19.31. Okay, sometimes though you have to work backwards. Sometimes you're not solving for C, you've been given C, you're solving for A or B. But you follow the same process. You plug in what you know. 24 for A, B is just B squared because we don't know what it is, so we use a variable. C is 26. Follow the order of operations and simplify. Now we have to solve for B. To solve for B, we get rid of the positive thing by subtracting it. To get rid of squaring, we square root both sides. We get B equals positive 10. Same thing here. 15 was C because it's the longest side. A was 9, B was B or X, it doesn't matter, these don't matter. Okay, follow the order of operations, subtract, square root to get B by itself, and you get your value. Okay, go practice this. If you need any help, please let me know.